Today's topic is displacement. Displacement is a pretty easy thing to understand in physics, but sometimes it gets confused with something called distance. And what we're going to try to do is to give you an example and walk you through an example and try to make it a little more concrete and understandable for you than just giving you a definition. Displacement is represented by the letter S, just to kind of clear that up right away. They don't use D, and I think it has to do with this fact that when you get into calculus, for example, if you would have a position function and you would take its derivative, it would be like ds divided by dt, how this function changes over time. I think that would be too confusing if you use too many d's there. So the dd over dt is probably the main reason they don't use that. So, but for our purposes, s will be just fine, and that's what IB also uses too. So displacement is s, and it's basically defined as the change in position of an object. And to help you understand that a little bit more, we're going to talk about maybe taking a college visit. So we're going to mark a little location here. We're going to call this GB. We're going to have another location over here. This would be LC. Let's say we're going to go to the University of La Crosse. And what we want to do is kind of trace, we're going to take a car ride and jump on here and basically go out to La Crosse. And by doing that, we're going to travel approximately 210 miles. Now that's pretty simple. Displacement is our change in position. Hopefully you remember from some science class that change in has a symbol, delta, that equals change in. In this case, we're going to have our delta S, which is going to be our final position, or S2 minus S1. And in this case, this trip is very simple. It's simply going to say, okay, if this is 0 miles, then this turns out to be 210 miles when we go to La Crosse. So you're going to take 210 miles minus 0 miles, and our displacement is equal to 210 miles. Now, if you remember, displacement is a vector. And vectors from an earlier video means we have to have some sort of direction. So we're just going to say we went 210 miles to the west. So that's our displacement for our first trip. Okay. Then on the way back, we decide, you know what, we're going to actually visit another campus. We're going to visit the University of Wisconsin-Madison, which is a little bit south and a little bit east of La Crosse. We'll just kind of give it a rough estimate of right there. And it's about 140 miles to get to there, and then from Green Bay to Madison, it's about 135 miles. Now, when you look at your total distance traveled this time, we traveled 275 miles. So distance doesn't indicate which way we went. It's just simply the total number of miles we went. But we want to know just the displacement again. And the only thing that matters, if you look back at our little formula which we threw out there, was the final position and the starting position. So if I do the delta S for the return trip, now we're at Green Bay, which would be 0 meters as defined, or sorry, 0 miles as we defined it before. And we're going to start at our 210 mile mark. So it's going to be 0 minus 210 miles. So when I do this, I end up with negative 210 miles west. If we kind of looked at that as our original way of moving, we started here, we moved in the opposite direction. Or an easier way of saying that would be probably 210 miles east. But then we have to reestablish our 0 again. We have to say that this would be 0 and this would be 210. And if we worked with our original system, where this was our starting spot and this was our 210 meter spot, we moved in what most places or most classes would consider to be a positive direction, but we set that up as negative, and that's not that big of a deal. Negative is really kind of up to you as far as how you want to do that. So the biggest thing we want to take note of in displacement is the only thing that matters is our starting position and our final position. It doesn't matter that I traveled a total of 275 miles to go from here to here. If I want to go my total round trip displacement, my delta S would be equal to 0 minus 0 miles, because I ended up exactly where I started. So anytime you kind of have a little closed figure where, we went from here to here, down to Madison, and then back up to Green Bay, because we ended at the exact same spot we started at, the total displacement of that would be 0. So to kind of recap or to review this again, displacement is our change in position, if you define it. Change in, remember, is the final position minus our starting position. So when we talked about our college visits to La Crosse, we started in Green Bay. We drove out to La Crosse 210 miles to the west. So we took 210 minus 0, and then we had to indicate west for our vector displacement. Then if we used our same starting location as 210 miles from the west, then we ended up going negative 210 west or a positive 210 east, because our total displacement turned out to be negative, indicating that we really just backed up and went to the same position that we started at. So that's our video on displacement. Hopefully that gives you an understanding of what we're doing.